The original equation is y equals cosine x to the power of x, and we have to use logarithmic differentiation to find the derivative of y, also known as y prime. The first step is to insert natural log on both sides of the equal sign, so you get natural log of y equals natural log of cosine x to the power of x. But since the law of natural log states that you can move an exponent in front of a natural log, it becomes natural log of y equals x times natural log of cosine x. Now we have to take the derivative of both sides in respect to x. The derivative of natural log of y becomes 1 over y. And you set that equal to the product rule of x times the natural log of cosine x, since the product rule is the derivative of f of x times g of x equals f of x prime times g of x plus g prime of x times f of x, then the derivative of x is 1 times the natural log of cosine x plus the derivative of the natural log of cosine x. The derivative of the natural log is 1 over x, so you have to take the derivative of 1 over cosine x, but now you have to use chain rule. The chain rule is h prime of x equals f prime times g of x times g prime of x. So you must multiply 1 over cosine x by the derivative of cosine x, which is negative sine x. In the end, you get negative tan x. Back to the product rule, you eventually get 1 over y equals 1 times the natural log of cosine x plus negative tan x times x. Now you can rewrite the equation fixing the signs, getting 1 over y equals natural log of cosine x minus x times tan x. Then you can multiply y over to the other side of the equation and get the derivative of y in respect to x equals y times the natural log of cosine x minus x times tangent x. Now since you have that y out front, you can use the original function to substitute cosine x to the power of x in for y. In the end, using logarithmic differentiation, the derivative of y equals cosine x to the power of x equals cosine x to the power of x times the natural log of cosine x minus x times tangent x.